No formal introductions, we're straight into circle theorem, tangents, and alternate segments. But before we go into the business of the day, it's important that we are sure that certain aspects of the matter of circle theorem that borders around your arc, your chords, and your cyclic quads are well taken care of. So let's have a quick review using our new general maths textbook, chapter 12 and exercise 12a. Question number 1 says, we are to look for the letters M, L, and K. Now, before you start solving problems like this, my advice is for you to label using capital letters. And we have a convention. You either label in a clockwise manner or you label in an anti-clockwise manner. Why are you labeling? Is to help you handle the problems better. Alright, so if that is done, in no particular order, I can look for anything. So let's say I want to look for L first. This is L. So how do I obtain L? What trigonometric or what formal geometry rule or theorem would help me get L? L plus 146 will be equal to what? 360. And why is that? Angles at a point. Beautiful angles at a point. So writers will just say angle at a point. Why is it angles or angle? Essential thing is that we know from formal geometry that the angles at a point sum up to 360, and it is called conjugate angles. So take note of that. Conjugate angles. If you go to my channel, I've done an extensive work on that. Point, lines, and angles. So that should take care of that. So from here, L will be equal to what? Am I subtracting or am I adding? Beautiful. So with your calculator, you should be able to get that. This is 240. Is that not? Beautiful. Now, in no particular order, I want to obtain K. What will K be equal to? Half of, beautiful, half of 146. Now take note of this, that I'm trying to twist convention a little. But back in those days, you write everything, right? But provided you know what you're doing. Now, what is the reason for this, which is very important? What's the reason for this? Angle at center equal to 2 times angle at second. We also have shorthand in mathematics. So with that, K will simply be equal to 73. Beautiful. Now, I want to get M. There are 2 ways to obtain M. I can use the property of cyclic quad, or I can use the property of what? This angle. Angle at center equal to 2 times angle at what? Circumference. So I want to use cyclic quad to do this. So K plus M will be equal to 180 degrees. What's the reason for that? Opposite up angles of cyclic quad. Up angles of cyclic quad. Or you can just simply say cyclic quads or cyclic quad. Once you say cyclic quad, the examiner understands what you're talking about. So with that said, 73 plus M will be equal to 180. So M will be equal to what? Am I adding or subtracting? Beautiful. So 180 minus 73 will be equal to what? 107. Did I get that right? Alright, so if you use the other method, you will still obtain the same answer. Alright, so that takes care of number 1A. It's usually not my convention to draw before solving, but I've drawn them down so that we can conserve the time and get down to other serious business. Now, same convention here, I will label, but this time around I'm going to label in an anti-clockwise direction, A, B, C, D. In no particular order, I want to look for arrow first. So, how do I look for arrow? I can draw from my knowledge of formal geometry that says R plus 28 is equal to 83. And why is that? Exterior angles of triangles. Beautiful. Exterior angle of what? Triangle. You may choose to specify the triangle, you may choose not to. You are not held liable for that. So exterior angle of triangle, so that means that arrow, am I adding or subtracting? Beautiful, so that will be 83 minus 28. That should give me a whooping 55 degrees, is that not? Beautiful. Now, at this point, I choose to use my knowledge of same segments. So I need you to think in a line of same segments now. I choose to use my knowledge of what? Same segments. So segment of interest for me will be this segment and this segment. So I will say for segment AB. Let's start with AB, in particular order. I can say that R is equal to Q. What's the reason for that? Same segment. Recall that I already know what R is, that not? So I can say that 55 degrees is equal to Q, and Q will be equal to 55 degrees. Settled. So I will pick another segment now, because look at it. I'm not trying to look for P. So what segment would I be using? What segment will I be using? CD. What does the segment do? The segment decides how the triangles will originate. Look at this. So of interest to us will be the angles that are being formed on the circumference of the circle facing the what? The segment. So we can say that P is equal to 28 degrees. What's the reason for that? Same segment. Beautiful. And with that, we have cleared that problem. Please don't waste your time after solving. You need to wait, tell us P is it. As long as the examiner cited the answer, you get your full marks. So don't waste time doing what. Although in Cambridge, they usually create an answer position for you. So you're required to write the answers there. Alright, but when we come to Cambridge, I'll tell you some tricks that you need to take note of while solving those problems.